Good morning, everyone. My name is Azwan Zmi Ben Junaidi. My matrix number is 24 DKM 21F1077. So today I want to present my case study. The title is coolant refiller machine. One, my title. We go to the problem identification. In our workshop, the coolant is stored in a big drum tank. So in order to use the coolant, we need to transfer the coolant into a smaller bottle. Our current method of refilling coolant into the smaller bottle is manually pour the coolant or using a hand pump. We see this as a problem that involves the inefficient and can lead to waste of coolant as when we transfer the coolant. It might get leaked or drop when we transfer it. This method also can lead to hazard because the coolant that split at the floor can cause someone fell down and get hurt or was getting hospitalized. Plus, it will require more than one person to fill the coolant if the hand pump is broken and cannot be used. We see this as an inefficient and dangerous and need to be improved.
Hi, my name is Muhammad Ramizan and my matrix number is 24 DKM 21F1104. Okay, today I want to present about proposed automated solution. Based on the problem, we decide to make an automatic coolant refilling system that use our knowledge in PLC programming, Omron CX programmer. So if how we propose automated solution is we has to install to create automatic coolant refilling that automatically measure the amount coolant for every bottle and the process of refilling the coolant more systematic and not messy. The first push button will be the machine to get ready by giving us a signal indicator after short on delay. Next, by pushing the next push button machine, we will start the operation of refilling and within time limit before it cut off all operation and stop. PLC programming, how to use PLC programming. So I will tell you step by step. Okay, first step is open CX1 software. Second one is select a new file. 3 on rung 1, place LD input 0.00 SPB start. And number 4, put N not T001 label ST. 5. Place relay at the end with address 20.00. 6. Make OR input, this time as latching under LD. 7. On second rung, place input 20.00. 8. Next, place timer team 00 hashtag 30. 8. Rung 3, place input T000. 10. Place output with address 100.00 as signal ready. 11. On rung 4, put input 0.02 as start ops. 12. Then place the input IR1 address 20.00. Place relay 20.01 and label as IR2. Do OR input latching under start ops as IR2. Place timer team 001 hashtag 30 at the end. Lastly, place n bracket 001, close the bracket to end the program.
Assalamualaikum and hi. My name is Muhammad Akil bin Muhammad Asri and my matrix number is 24DKM 21F1122. I want to talk about the implementation plan. Creating a safety conveyor using an emergency button and a PLC involves a design control system that stops the conveyor in the event of emergency. Below are the using the general steps to create a safety conveyor using an emergency button and a PLC. First, select the PLC. Choose a stable PLC that meets the requirement of the conveyor systems and has the necessary input and output capabilities to integrate the emergency button. Second, program the PLC. Use the PLC programming software to create a program that monitors the emergency stop button input and controls the conveyor operation. The program should include logic to stop the conveyor when the emergency stop button is activated. Lastly, test the system. Once the PLC program is created, test the system to ensure that the emergency stop button functions correctly and stops the conveyor when activated. Next, I want to go about project documentation. Implementing a dispenser timer using a program logic controller or PLC can come with its own sets of challenges. There are several challenges faced during the implementation of coolant refiller machine using PLC. First, I/O configuration. Correctly configuring the input and output I/O settings is very important. Because why? Because incorrect wiring or configuration that can cause the PLC to not receive the correct signal or not control the light as intended. For example, input and output settings that are messed up cause system failures such as fan not working or inaccurate timing. Second, PLC programming. Main challenge to us is to make a PLC ladder diagram for the coolant refiller machine. For starter, we need to figure how the timer should work and how to get it functional properly. For example, when we start our simulator by pushing PB1, we don't get the result that we wanted, which is the timer didn't start.
My name is Muhammad Denis Skandar bin Zabidi. My matric number is 24 DKM 21F10X6. I'm from DKM 5B. Testing and evaluation. First, safety interlock. Regularly test the safety interlock system to ensure it functions correctly. Develop a maintenance schedule to keep switch, sensor and relay in good working condition. Second, machine operation. For the machine testing, we test the rate of whir of the machine and determine the correct value of the rate. Number 3, PLC program. After doing ladder diagram, we run the software simulator to make sure the peak program runs smoothly. Number 4, wiring. We make sure to check the wiring system so the machine will be in good condition and prevent from the hazard. Number 5 is pump system. The flow of the pump is running smoothly because when the coolant dependent, we get the same volume. Conclusion. In conclusion, we are able to finish our case study and implementing the coolant refiller machine into our workshop. Although there is a lot of challenge and some error that we face when making the product, we managed to pull it off by searching for reference and asking a lot of people. Also, we are able to test it and fortunately it worked exactly like we wanted. The extraordinary automation and cycle control is major in the genuine work. Risk creation, chance and satisfaction of good creation with insignificant waste is really trying. The imaginative new development and even to place asset into such motorization is the snake right now with the associate economy. Present work research the control plans for current automation and structure checking to improve system movement, structure reliability, and others. Truly, computerization and system checking nowadays are the wise choice to improve structure execution and to achieve customer and speculators achievement. From our group, thank you.